Okay, so in preparation for our next week's inverse trig function calculus work, this week I've decided to do a review of what you should know from inverse trig functions in general. So I'm going to start at the beginning and just go through this. Okay, so first of all, let's note that if f of x is a function and f is 1 to 1, in other words, it passes the horizontal line test, then f has an inverse function f inverse of x. Now, this is key. F inverse of x is not equal to 1 over f of x. We've done a disservice all these years saying the inverse is f to the minus 1s because x inverse is 1 over x. But that's just because you're working with the real numbers. You're talking about function, you're talking about function composition, which we've talked about before with the chain rule. So two functions are inverses if their composition equals x. So in other words, if f composed with f inverse, f composed with f inverse of x equals x, and f inverse composed with f of x equals x. And so this has a geometric interpretation. The functions are mirrors over the line y equals x. Okay, and all this is a review from last semester. You did this with Math 100. I know because I was teaching 999L and we did days of understanding on how to find inverses. Okay, so what we want to do is talk about trig inverse, so inverse trig functions. And so, for example, if I let f of x be the sine inverse of x, this is inverse sine. You can also write it as arc sine of x. Either works. I always write it like this, though, because we're talking about radians. Okay, and remember, 1 over sine of x in general equals cosecant of x. But sine inverse of x is just this. It's sine inverse of x. It's its own thing. Right? And make sure you're clear on why these are not the same. Okay. And so by this definition above, if I take the sine of the sine inverse of x, I get x. And similarly, if I take the sine inverse of the sine of x, I get x. All right, so now we want to get a handle on, what is this sine inverse? So first of all, let's look at sine. Consider the function f of x equals sine x. The domain is all real numbers, and the range is -1 to 1, right? So if you graph good old sine, which we did in last week's Didn't last week, so I'm correct. It goes here, 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 so it does this. So here's minus pi over 2 pi, like this. That's sine. Okay, first of all, f of x is not 1-to-1. Okay? So if you remember, what we do is we restrict the domain. To make f on this restricted domain a 1-to-1 function. Okay? And what you want to do is cover the entire range and stay as close to 0 as you possibly can. So if we take away all of this, take away all of this, okay, oops, I went too far. I went too far, hold on here. So here's pi over 2. So if we go from pi over 2 to minus pi over 2, if we choose this restricted piece of domain, we cover the entire range, and the function is now 1-to-1 on this restricted domain. So f of x equals sine x is 1-to-1 on the domain minus pi over 2 to pi over 2. And this is crucial. So now on that domain we can find what f inverse is. Okay. So we go like this, we go, okay, y equals the sine of x. So that says x equals the sine inverse of y. Let me do it that way, that's too complicated. Let's just say this. Let's let g of x be sine inverse of x. Okay. And so now now I'm doing this backwards. Hold on, it's been a while. Hold on here, hold on. Now the inputs are numbers and the outputs are functions. Right? So what we're saying here is what is g of 1/2? This is the sine inverse of 1/2. And this is equal to an angle. And this says the sine of what angle is 1/2. So it's pi over 6, right? So at 1/2 we have pi over 6 here. And so it looks like this. Okay. And that is sine inverse of x. The inputs are numbers and the outputs are angles. And sure enough, if you take the sine of the sine inverse of 1/2, you get 1/2. Okay. So let's look at cosine and try and figure out what cosine inverse looks like. So we draw cosine. And I'm going to go from pi to minus pi because that's all we need. So this guy goes like this. So again, this thing goes off forever, and it's not one-to-one because it doesn't pass the horizontal line test. And so we want to restrict the domain, and we want the range to follow minus 1 to 1. So we pick the closest range that's nearest to the origin, and let that be our restricted domain. So for cosine, this thing is 1 to 1 on 0 to pi. So cosine inverse of x is restricted to from 0 to pi. Quadrants 1 and 2. And when we graph it, oops, did it again. It's hard to think backwards. One to minus 1, 0 to pi. So the cosine of 0 is 1. Cosine of pi over 2 is 0, and it's like this. So it goes. Okay. All right, let's look at tangent. And we want to look at tan inverse of x. For those of you taking Calc 2, this function becomes really important. Okay. So when you graph tangent of x, remember there's asymptotes at all the multiples of pi over 2. And the range is all real numbers. So that means when you flip it, the domain is all real numbers. And the range is minus pi over 2 to pi over 2. So we restrict this domain to minus pi over 2 to pi over 2. Non-inclusive because of the asymptotes. And same with the range. So when you graph tan inverse, you have asymptotes of pi over 2 and minus pi over 2. And it looks like this. In particular, if you take the limit as x goes to infinity of tan inverse of x, you get pi over 2. And if you take the limit as x goes to minus infinity of tan inverse of x, you get minus pi over 2. All right. You don't work a lot with secant inverse, and you certainly don't work with cosecant and cotangent. There might be 1 or 2 problems in the homework, but on any assessments or any kind of work in the class, it'll just be these 3 guys. Okay, so summarizing here, y equals sine inverse of x has a restricted domain minus pi over 2 to pi over 2. y equals cosine inverse of x goes from 0 to pi. And y equals tan inverse goes from minus pi over 2 to minus pi over 2, open brackets. Okay. So let's look at some examples here of how we work with inverse trig functions in the unit circle. So what's the sine inverse of 1? Remember, this equals an angle, so this says the sine of what angle equals 1? And theta could be pi over 2, 5 pi over 2, 9 pi over 2, right? It could be any one of these, but because of our restricted domain, we know it has to be one and only one answer, and that's pi over 2. So let's see here, what's the sine inverse of minus root 3 over 2? Okay, remember sines only defined in quadrants 1 and 4, because we're going from pi over 2 to minus pi over 2. So we go down here, we make a triangle. Call this theta, and its opposite over hypotenuse, and that's 1. So this is minus pi over 3. How about cosine? What's the cosine of minus 1? Right, this is equal to some angle, so this says the cosine inverse of minus 1. So this says the cosine of theta is minus 1. Okay. Remember, cosine goes from 0 to pi along the x-axis here. So cosine equals 1 here and minus 1 here, so theta equals pi. Okay. How about the cosine inverse of minus 1 over root 2? Okay. Cosine again has to be in quadrant 1 or 2. We know it's negative in quadrant 2. So we build our reference triangle here. There's theta. We'll call that alpha. Cosine, this cosine is adjacent over hypotenuse. Okay. So alpha is pi over 4. So theta is pi minus pi over 4, which is 3 pi over 4. Okay. So the cosine inverse of minus 1 over root 2 is 3 pi over 4. All right. Okay, and now let's have some fun here. What is the sine of a cosine inverse of 3/5? When I first taught this, I don't know who your trig teacher was, but I made people put this in sentences. So what it is looking for the sine of the angle whose cosine equals 3/5. Alright, so if you unravel this thing, cosine inverse of 3/5 is an angle. Right? It's the angle whose cosine is 3/5. So here's what we do. We go, okay, I can do this. Use my triangle here. Cosine is positive, so I'm in quadrant 1. And I go like this. I go and build a triangle here. There's theta. Cosine is 3/5. So this side is 4 because it's a 3, 4, 5 triangle. All right. So the sine of this angle is 4/5. So the sine of the cosine inverse of 3/5 is 4/5. Right. And notice, I never found out what the actual angle was. We don't need it. We know that it's related inside the 3, 4, 5 triangle this way, but we don't know what it actually is. It's something like 27 degrees, I think. No, 47. Something bigger than 45, 50, 50-ish. Doesn't matter. Right? Okay. What else can I do? I think that's about it. Hopefully this was just a quick review of stuff. I made problems for homework due Monday on this from the JIT book. They do a decent job. So for example, they ask things like, what's the sine of the tan inverse of x? Right. I'll make this a guided practice. Make that number 2 and make this number 1. What is the cosine of the sine inverse of minus 1/3? So here's your 2 guided practices, and I will see you in a minute.